All right, so there's one last section for chapter 5 that I did want to cover. And this is the section that has to do with solutions. Does anybody know what a solution is defined as? So it's a mixture between a solid or a liquid. Is it homogeneous or heterogeneous? Terminology. Is it evenly mixed or unevenly mixed for a solution? Evenly mixed, right? So in this case, a solution is a homogeneous mixture of two or more substances. Typically what you have is you have something called a solvent. Solvent is typically the liquid doing the dissolving. And then you have some sort of solute. This is the thing being dissolved. So if you've ever made simple sugar, right? Simple sugar, you take sugar and water. What is the sugar? Is it the solvent or the solute? It's the solute. It's the thing being dissolved by the water. So make sure that you keep those kind of squared away in terms of their overall definition. And solutions can vary a lot in their concentration. So we have to define concentration. Concentration is a measure of how much solute is dissolved in a given amount of solvent. So I'm sure if you've ever made simple syrup, you can make it really, really strong, syrupy sweet, or you can make it really, really weak, right? So concentration is basically a measure of how dilute or concentrated something is. Chemists like to calculate concentration using a term called molarity. And this is a quantitative definition for concentration. And this is one that's particularly used by chemists. Biologists don't use it as often. Biologists will use percentages just because it's easier for them. They don't like using moles for whatever reason. But let's calculate this, or define it, I should say. Molarity has this unit of big M. So capital M is always molarity. I always tell people, be very, very careful when you write out moles to write out the full word moles and not just M, because if you write M, that gets confused with molarity, which is something completely different. And molarity is going to be moles of solute over liters of solvent. So let's do a couple practice problems where we calculate molarity. So let's do one really quick. What is the molarity of a solution, and I'll abbreviate solution, when 2.33 moles of NaCl are dissolved to make 3.77 liters of solution. What do you guys think? How should we set up this problem? Yeah, it's pretty straightforward, right? So we know molarity, that M is going to be moles over liter. We know we have 2.33 moles. And our total volume is 3.77 liters, which gives us a molarity of 0.618 molar with a big M. So our unit in this case we need to keep track of. Does that make sense? Yep.
So on the question you said there was 3.77 liters of solution.
Mm-hmm.
Will adding a solute ever make maybe like a bigger volume?
It can. So that's a great question. If you're looking at molarity, that bottom part, the denominator, needs to be the total volume of your solution, including the solute. That's the full formal definition. Okay, let's try a harder one. This one's going to require more unit conversions. So calculate the molarity when 7.66 grams of calcium chloride, so CaCl2, are dissolved to make 345 milliliters of solution. So I'll give you guys a minute to work on this, and then when you think you got it, check with your neighbor and see if you guys are coming up with the same answers. All right, let's see a show of thumbs. Who thinks they got it? Sideways thumb if you're still working on it. Thumbs down if you have no idea what's going on. Some thumbs down. All right, let's do this one as a class. It's okay. This one's actually got a bit more going on. One problem I see with this problem is we're not given the moles of our solute, right? We're given grams of our solute. So the first thing we need to do is figure out how many moles of calcium chloride we have. So let's break this down. Okay, we know we've got 7.66 grams of calcium chloride. How can we convert this to moles? Yeah, the molecular weight. So I'll put grams of calcium chloride on the bottom. We can put moles of calcium chloride on the top. That will cancel out grams and gives us moles, right? Okay, did anybody go through and determine the molecular weight of calcium chloride?
106.98.
106.98. So let's double check that. So CaCl2. We've got one calcium, which has a molecular weight of 40.078. We've got two chlorines that have a mass of 35.453, which gives us a net molecular weight of 110.984 grams per mole. Okay, so that 110.984, should that go on the top or the bottom? Oh. Should go on the bottom, right? Because this is with the gram side. So we want to plug this in as 110.984 grams for every 1 mole. And when we're all said and done, we should get 0.0690 moles of CaCl2. Okay, so we're halfway there. All right. The other problem I see is we're not given the liters. We're given milliliters, so we've got to do a unit conversion from milliliters to liters. So let's do that. So in this case, we were told that we had 345 milliliters. We don't want milliliters, we want liters. So I want to cancel out milliliters, put that on the bottom. I'll put liters on the top. Now the big question is, how many milliliters are in a liter? 1,000. So that was one of the units we had to memorize. Does that 1,000 go on the top or bottom? On the bottom. There are 1,000 milliliters for every 1 liter. So now we cancel out milliliters, we're left with liters. And this should give us 0.345 liters. Okay, now we're ready for molarity. So molarity, we said, is going to be moles over liters. We just said that we had 0.0690 moles of calcium chloride. And we've got 0.345 liters. What does that give us for our molarity? So is it 0.2? I heard somebody say that. 0.200. Why is it 0.200 instead of 0.2? 3 sig figs, right? So we've got to keep 3 sig figs in our final answer. So I'll do 0.200, and our units would be molarity. So sometimes these solution problems do involve unit conversions from grams to moles, or from a liter or a non-liter unit to liters. So you have to be comfortable doing unit conversions in order to solve a lot of these solution problems. Does that make sense? Okay. So what we're going to do with the rest of the period is work on that carbonates worksheet. I would recommend working on this as a partner. You can hand in 1 worksheet per partner. Just make sure your name is in the top right-hand corner. And please, please, please show your work. If you don't show your work, I won't know where mistakes happen.